Hello, this is Chuck Ridgway, Automation Technology Manager at Horner. Thanks for joining us for another Tuesday live stream. Well, I'm here at the Horner Training Center once again, and I'm bringing you a video today that I was supposed to bring you a couple weeks ago. Here it is. Valve control using Horner's new EtherNet IP scanner. Now, the reason we delayed this topic a couple of weeks is because to do a nice demonstration of the equipment today, you really need pneumatics. And a couple of weeks ago, I discovered I hadn't ordered exactly the proper pneumatic parts. So instead of giving you a half-baked demo, I decided to delay it a couple of weeks. All right, so here we are today. Now, there's two main benefits to today's presentation. The first is, of course, that we're showing off Horner's new EtherNet IP scanner capability, which gives products like the Canvas series and the CPU 300 right there, the ability to control an Ethernet IP network. And it's coming very soon for the XL Prime series, and it will eventually be coming in other series as well. Well, that's the first benefit. The second benefit is a chance to check out a pretty new platform from a major pneumatic supplier, FESTO. So we have to thank FESTO today for sending us a VTUX valve bank, which is a pretty new piece of gear, and we're gonna check it out today. All right, we've got a lot of work to do. Let's get started. Okay, here's how we're breaking it down. Today is very much going to be dedicated mostly to demonstration time, but we'll do a quick review of Ethernet IP, followed by a summary of the Horner products that support Ethernet IP scanner capability. And then we'll spend a couple minutes reviewing the hardware that we're going to be using for today's demonstration from FESTO. But again, most of the time is going to be spent on demonstrations. Here we go. Okay, so Ethernet IP is the most popular in terms of installations industrial Ethernet network in North America. So it is an open standard. It's often affiliated with Rockwell, but it's really an open standard, and any manufacturers can support Ethernet IP. Now, the two most common device types on Ethernet IP are I/O adapters, which are devices that hang off the network and share their data with an Ethernet IP scanner, which is responsible for controlling the network. And scanner capability is relatively new for the Horner family, very new as a matter of fact. And here are the products that support it, starting with Canvas. So as we record this today, both Canvas and the CPU 300 can act as an Ethernet IP scanner. The requirements are that you need to have at least Seascape 10.2 Service Pack 2, and with that version, you need to get an extension code from tech support. So that will unlock the Ethernet IP scanner capability. We're giving it a little bit of a soft launch, if you will. Now, as soon as Service Pack 3 comes out, no more extension code required. It'll just be there available for anyone to use. Now today, with Canvas and CPU 300, you need firmware 17.4 or later. Now, when this capability comes to the XL Prime series, you will have to pay a one-time upgrade fee of $249. So you'll purchase a voucher and then apply that voucher as a license. Again, a one-time upgrade fee in your controller to support Ethernet IP scanner. For that, you will need Service Pack 3 of Seascape 10.2, and for Prime, you will need firmware 17.5 or later. Now let's review the FESTO equipment that they've been kind enough to provide us for today's presentation, and that is the FESTO VTUX. It's FESTO's newest valve family. It's built on their CPX platform, which is designed to integrate both pneumatic and electrical components in the same assembly and on the same network. It's really quite a clever system. Now, this uses the new Ethernet-based AP backplane, which is an upgrade in terms of speed and in terms of the amount of data available on the network, and it offers both high bandwidth and short cycle times. Now, the actual component that we'll be interfacing with, that's part of the VTUX system or used with the VTUX system, is the CPX-AP Ethernet IP interface. Now, interestingly, actually, this isn't that uncommon in the industry, but this same component can support both Ethernet IP and Modbus TCP. So you have your choice of which of those two networks to use with this component. Now, if you want to use other networks, there are other adapters available for the other Ethernet networks, maybe Profinet or EtherCAT, that sort of thing. But this particular component supports both Ethernet IP and Modbus TCP. Now, it also has M12 type connections, the quick connect type connections, utilizing the standard Ethernet pinout for M12. And like a lot of Ethernet IP devices, it includes a built-in Ethernet switch. So you can daisy chain your devices if you choose, or you can decide to do a home run type scenario and only utilize maybe one of the two connectors. Now, there's multiple ways to set the IP address on the product, including some rotary switches that are available behind a door on the product that can be used to set those manually. So you've got a variety of different choices in that regard. Now, we've got a couple different valves that we were sent for today's demonstration, and you can see the information there on the screen. Now, in reality, I probably should have used a couple different cylinders or maybe slightly different configuration of cylinders with these particular valves, but I think for demonstration purposes, it's going to work out just fine. So for today's demonstration, I'm going to be using two of these particular FESTO cylinders. These are double acting cylinders with a 25 millimeter stroke. Okay, so that's it for our preliminary information today. Let's spend the rest of the time on our demonstration. Okay, here is the VTUX valve bank that we're working with today. One of the great things I like about the VTUX is that even though it's completely modular and can be easily expanded in the field, when you order it, you can order it using an online tool that allows you to custom configure it, and then when you receive it, it comes fully assembled, which is really awesome. Okay, let's start on the networking side. We've got their very latest Ethernet IP adapter, which I believe is the CPX-AP. It comes with a couple of Ethernet connections here, which means it's got a built-in switch. Also, the power comes in underneath here. Oh, and one thing I neglected to talk about with Ethernet IP, and that is there are some rotary switches here. So if you want to custom set the IP address in the field to a 192.168.1 address, you can manipulate those rotary switches for that purpose. Of course, it also supports DHCP and setting the IP address over a web browser and all kinds of things. All right, and then on the pneumatic side of things, let's take a look at here. Of course, we've got a couple of valves that have come with our demonstration. And then you can see here we've got our pneumatic ports on the bottom with our supply, and then 2 ports for each of our valves. So again, a nifty piece of kit. Now you can order these also, the valves, with inputs on the input side of things, so you can get feedback directly on the status of your valve if you want. We didn't choose to take advantage of that for the demo. Again, we didn't want to be greedy. Now from the standpoint of our cylinders that we're going to be showing off in today's demonstration, or using in today's demonstration, this is the FESTO 80N-S-32-25. So it is a compact a compact cylinder with about a 25 millimeter stroke, I believe. So we've got a couple of these we'll be using for the demonstration today, and then all this gear is going to be used for our trade show setup here, and we've been using it, without the pneumatics so far, and I'll be adding the pneumatics to it for our next trade show, which is the big Automate show in Chicago this year. All right, that's a rundown of the equipment we're using today. Now, if we're going to get this valve bank talking over Ethernet IP, there's a couple things we need to do up front. One of the things I like about this product is it has a very nice web interface. So you can just type in the IP address of this device, and boom, up pops this nice interface. Now, when the unit ships, it ships, I believe, with an IP address of 192.168.1.1 with DHCP enabled. So what I did to initially talk to this device is I just set up the adapter, the wired adapter on my laptop to be on a compatible subnet, say 192.168.1.100, maybe was what I set the IP address on my computer. And then by typing in the default IP address of 192.168.1.1, I was able to immediately get to this terminal interface. And then I was able to go in and set the IP address the way I wanted it. How did I do that? Well, basically by clicking on this first slot here, which is the adapter, the Ethernet adapter for the system. If I click here, boom, now you'll see, all right, here's where I can set the IP address, subnet mask, gateway address, all that stuff. And in my case, I also unclick DHCP enable. Now, when I initially changed these parameters, it asked me for a username and a password. And the default username is admin, and the default password is here, this product key, which is also laser printed on the top of the product itself. So that's the default password in this case. And then immediately after making these changes, I then went in and changed the password to be something custom instead of this default password that anybody potentially could see. So that was the second thing I did. All right, so now that we've got the unit so that we can actually connect to it over Ethernet, the next step is to start working on the Ethernet IP interface. One of the cool things, another cool thing about this product is it has an Ethernet IP tab here, okay? And if we select that, we have an EDS file available right from here. So stored within the product is the EDS file. Now, it's telling me, and maybe it'll tell you the same thing, that this is an insecure file and it's been blocked. All I have to do is hit keep, and it will keep that file that was downloaded, and then I can go ahead and unzip it and use that, and I'll show that to you a little bit later. But how cool to be able to actually have the EDS file stored right on the product itself for easy download. And then the next thing was, if you go back to that Ethernet IP tab, if you will, or pull down, you can have an assembly view, and you can take a look at all the potential different assemblies that are available for interfacing with this guy over Ethernet IP. Now, for one of the ones I like to look at here is the very top one, which is the exact output configuration here. And this tells you, for the first 4 bytes at least, it tells you what each of the bits within the 4 bytes means. And in my case, I've got only 2 valves as part of the bank, and there are 2 coils per valve that I'll be manipulating. So of all this data, really, it's only the first 4 bits that I'm all that concerned about. Now, you have your choice of all these different assemblies. In my case, I just took advantage of the default assembly that was part of the EDS file. I could do everything I needed to do from that interface, and that's what I chose to do in my case. So anyway, getting this unit connected and getting the Ethernet IP information available is really very awesome with this particular product. There's plenty of other things you can do from the web interface. I'm not going to go into details on that because frankly, I'm not an expert on that. But for instance, we can go in and take a look at some of the options for the valve bank itself, including whether we want to actually monitor whether the load supply is active or not and make that an alarm or not, that sort of thing. But there's just a bunch of things you can do here from this web interface, which are really handy. Okay, now let's take a look at what's required to configure the canvas to talk to the valve bank and control it over Ethernet IP. All right, so we're going to go to hardware configuration. Now I'm going to show you kind of a from scratch configuration, and then I'll pivot to showing you my finished configuration to save a little bit of time. All right, so here's my canvas controller. I'm going to be utilizing LAN 1 and Ethernet IP, so I select that LAN. Now, normally I would need to set my IP address, net mask, etc. appropriately. I'm going to skip this step, but that's not a step you can skip. And then down here under resident protocols is where we can select Ethernet IP scanner. And then once it's highlighted and we hit configure, there's a couple of variables we have to create. We have to create a disable bit variable, a Boolean variable, which allows us to disable Ethernet IP in general, okay? And then we also have to assign a status variable, which tells us how many adapters the scanner is talking to at any given time. Now, since I'm doing this on the fly, Cscape's just creating these variables as we go, all right? And now that that's complete, the next step is to start adding I/O adapters to the network. How do we do that? We highlight it, right-click, and say Add Adapter. Okay, and then we have a blank slate for this adapter. So what are we going to call this adapter? I'm just going to call it valve bank. All right, the IP address can either be a variable pointing at the IP address, or you can just type in the IP address, hard coding if you will. We'll skip over browse EDS for now. Connection timeout, I'm just going to set this to 100 milliseconds. This doesn't really impact how fast we communicate with the device. It just affects one of the timeouts. 100 seems like a good place to set that initially. And then we also have to assign a couple variables that are tied to this particular adapter. So we need, again, a disable variable, okay, which is a bit type, and we need a status variable, which is a double word type, okay? So once we've set those, then we can start browsing for our EDS file. And when we do that, it's going to show us the EDS files we just downloaded from the valve bank, and we're going to want to select the one that applies in our case. And I've got a -A unit, not a -I unit, so I'm going to select that address. It's going to give me a little bit of information here so that we know that we've got the right EDS file, and we do. All right, and now I'm going to have the ability to browse for a variety of different connections. I'm going to choose the default one, which is perfectly fine for my example. And this is the point at which we're going to pivot over to a finished configuration. So to save a little bit of time and show you how I finished up the configuration, because really all that's left after this is to set the input and the output tabs appropriately, set up our variables, and away we go. So I'm going to back out of here, switch to a different program. This is my finished program, okay? Go back to hardware configuration, go back to LAN 1, and then this is my finished program that includes several other devices on the network as well. I'll double click on Valve Bank and then show you my finished configuration. So yes, indeed, I did go with the default connection that was available in the EDS file. And on the input side of things, I selected integers because that's the most convenient for communicating with a Horner controller or from a Horner controller over Ethernet IP. Integers, if it's an option, is usually the best option. It automatically selected the length for me. I set the RPI at 50. I could probably set it lower. That seemed like a good setting to update all the data every 50 milliseconds. And then the key point here is you have to assign input variable that's going to receive in these 8 integers. And so that is a integer-based array with a dimension of at least 8. Okay, and then I did the same thing on the output tab. And frankly, the output tab is where we do all the work because really we don't have any inputs with this system. We're just turning valves on and off. So again, we selected integers. The data length was selected for us. RPI of 50 was a good place to start. And then again, another variable, an array type variable, integer with a dimension of at least 8 because that's how much data we need to have available. Okay, so that's what the configuration looks like for Ethernet IP with Canvas for interfacing with the valve bank. Next, let's take a look at the variable handling for the valve bank. So if you remember correctly, we really are only concerned, in my example at least, with output data, the data that's going to turn the valves on and off. So with the default assembly for the valve bank, it has 8 words of data, which I've mapped to a single 8-word arrayed variable. And then what I'd like to be able to do, I can easily get in and work with individual bits within this long bank of data. But instead, what I'm going to do is create a couple of meaningful variables, Boolean type variables, that are tied to specific bits within this bank of data. So to do that effectively, I'm going to use a trick. The trick I'm going to use is to map all of the output data going to the valve. Remember, we're only concerned with output data in my example, to turn the valves on and off. We're mapping all that output data as a complete bank over to an open bank of registers. And I just decided to make it register 2101. So 2101 through 2108 contains all the output data. And then what I've done is created individual bit type or Boolean type variables that are mapped to individual portions of that big bank of data by calling out the appropriate register number. So this is the first bit in the whole bank of data, which is register 2101.1. Now, the first valve I have only needs 1 bit to control it. Okay. The second valve I had, we actually need 2 bits to control it. So I've mapped 2 individual bits at the right locations. So this is how we're handling the variable data with the valve bank in my example. Finally, let's take a look at our ladder logic. Okay, here is the bit that is needed to control the first valve. Remember that first valve only needs one bit. And then here are the 2 bits that are needed to control the second valve. All right? Okay, so on the first valve, when this bit is on, it's extended. When it's off, it's retracted. At least that's what we're going to command it to do. So we just have a toggle button on our touchscreen that's going to control that particular valve. And then over here, I've also got another internal variable, which is just telling me the state of things. Is this state on or off, extended or retracted? I could have used this directly, but I chose not to. All right, and then down here, we've got a little bit of extra logic for that second valve. So I have just a momentary push button that's going to set the output pattern the way I want it to extend the valve. And I've got another momentary push button that's going to set the output pattern in the opposite way to retract the valve. And then again, I have created a separate state variable that I can monitor for the screen. All right, let's take a look at it on the bench. All right, let's take a look at our demo for today's topic. This may very well be one of my messiest demos ever on the Horner YouTube channel, but I think it'll get the job done. All right, let's start here with our VTUX valve bank. All right, and let's start with the electrical connections, okay? Now, we've got Ethernet IP in and Ethernet IP out. Now, in my scenario, I've daisy-chained all the Ethernet IP devices that are connected on the network. You wouldn't have to do that. You could utilize only one of the 2 ports and do a home run, but again, I've utilized both in a daisy chain type configuration. All right. Now, what you might not be able to see very well down here is a single M12 L-coded cable for power. Now, there's 2 different power feeds coming in on this single connector. There is the power that's used for basically all the communications and all the control type power. And then there's the power for doing the switching. So 2 distinct power supplies coming in through a single connector. All right, and then we get to our pneumatic connections. We've got 2 valves here, all right? And they each have, well, before we get to the 2 valves, we have a supply line here that's 8 millimeters in diameter. And then on the 2 valves, each with 2 connections each for pneumatics, we have 1/4 inch connections there on the valves. Okay, and that's pretty much a rundown of the valves. Now, what the valves are driving are a couple cylinders over here on top of the desk, way over here in the upper corner. So we've got 1 cylinder here and another cylinder there. These are compact cylinders from FESTO, which will work well in our trade show setup. Now, I'm not going to have all this, messy hosing and all that sort of thing for the trade show demo. I've got a lot of work to do to make it nice and neat with a different approach to my pneumatic installation, but in the end, it'll end up good. But for this demonstration, it was just important to show you how things were connected. And then now let's go to the OCS touchscreen and let's exercise things. All right, so here we are with our demonstration on the touchscreen. So we've got our VTUX valve bank here and our 2 valves in our demo system. Each valve has 2 bits associated with it. And then valve 1 is connected to cylinder 1 and valve 2 is connected to cylinder 2. Now, valve 1 has a spring to return, so we really only need to manipulate the first bit that's affiliated with valve 1, whereas on valve 2, there is no spring to return, so we need to manipulate both bits in order to change the state of the cylinder. All right, so let's go ahead and just demonstrate cylinder number 1. Again, only 1 bit to manipulate, so I'll press a button here to extend. You can see if you look there on the left top, you can see that first bit is on. When I toggle that bit to off, then the cylinder retracts again. So just 1 bit to deal with cylinder number 1. Now cylinder number 2, we've got to manipulate both bits. So look at that pattern carefully. It's currently retracted. when I hit extend, those bits swap. The first bit turns on, second bit turns off. When I hit retract, it goes back again. All right, very good. So that is the control of the bits associated with each valve and ultimately to each cylinder. Okay, now in terms of information we can get from the valve, first of all, in terms of its Ethernet IP status, that is status from the OCS saying, hey, is that particular I/O adapter working properly? And a 1 means it is, so that's good news. If we got something other than a 1, we would need to check that out. And then here, this is actually a single explicit message, the results of a single explicit message that we have the ability to send to the valve to get its valve status. And the last time that we requested this information via a explicit message, it came back with a value that indicates operational. This is a text table here. The numeric value indicates operational. So if I get it again, okay, no surprise, since we've just been working with the valve bank for a few minutes, obviously it's still operational. Okay, so here we are with Ethernet IP status and then the ability to grab information through an explicit message triggered within the OCS. And then of course, everything we've been doing here with manipulating these bits that are associated with each valve, that's all implicit messaging over Ethernet IP. Okay, some big thank yous as we wrap up our topic for today. First of all, Brian Stankus from FESTO, thank you for the VTUX equipment. We had a lot of fun working with it, and we're going to be showing it off not only, of course, in this particular video, but also in our trade show setup. And then some thanks as well to Dave Ellers and Lance Waffensmith. They not only helped us specify the equipment to order, but also provided some assistance with today's presentation. Thanks, Dave. Thanks, Lance. Now, you don't want to miss the opportunity to participate in Horner training in 2026. Just go to our website at the URL you can see there on the bottom, find the session that's the most convenient for you, and get signed up today. Now, we love to see customers and other folks that are interested in automation at trade shows, and we have 3 major trade shows we'll be participating in for the balance of 2026, at least in the United States. There's others internationally as well. So check out this schedule, and if one or more of these trade shows looks good to you, then be prepared to see us at the show. And you can not only check out the latest from Horner, potentially new products as well, but also you can talk to us about your application. All right, lots of ways to interact with Horner online at www.hornerautomation.com. Of course, that's our website. You can go to our Horner APG YouTube channel, and I think you'll find that today's video will be the 500th video that we're posting on our YouTube channel. I've had the honor, I guess, of participating in about half of those videos, but it really represents the hard work of a lot of folks at Horner. So check out all that's available on the Horner APG YouTube channel. And of course, you can always get the latest news from Horner on LinkedIn. Now, next week, we've got a fun topic for you. It's always fun to talk about product. It's always fun to preview some new stuff. So we've done a little bit of product line shuffling at Horner. We're going to review that with you next week, as well as preview some new products. So don't miss it. Okay, so that does it from the training center this week. If you haven't subscribed to our channel yet, don't hesitate to do so. It doesn't cost anything. And if you choose notifications when you subscribe, you'll be notified every time we go live or every time we post a new video. Okay, so until next week, until maybe you design one of these guys into your next project, CPU 300, or maybe one of these guys, the CPU 250. Well, until next week, let's all get out there and do some good.